Cool. Awesome. So yeah, as mentioned, I'm Alex DeBrie, and I'm here to talk about patterns for analytics with DynamoDB. I know this is like a data-ish meetup, so and I'm guessing that means a lot of analytics type stuff. And the first thing I want to say just straight off the bat is Dynamo is not for OLAP. It's really focused at OLTP workloads. So production workloads where you're doing lots and lots of concurrent small operations rather than like these big analytical operations and things like that. But with that caveat aside, like, hey, we're going to learn some cool things anyway that I hope will be useful if you're using Dynamo, if you're using some OLAP systems, especially if you're helping get data from Dynamo into some OLAP type systems for querying. So in terms of what I want to cover today, the first two topics, DynamoDB basics and from SQL to NoSQL, is what I really like to cover with Dynamo and just give a sense to people of like how Dynamo works, how it is really different than relational databases that you're probably used to, and get you thinking about that. Usually that's in service of like, hey, how do we actually model our data for this different type of OLTP database? Since this one's more analytics focused, we'll sort of use that to understand why Dynamo is the way it is, why it's not great for analytics, and then we'll go to that third section, which is patterns for analytics with Dynamo. What if I do have some patterns or some analytics needs? How do I sort of integrate those with Dynamo? So who am I? I'm Alex DeBrie. I wrote the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. I'm an AWS data hero and independent consultant. And let's just kick it off here and get started. So I want to start off with DynamoDB basics, and I like to start off with terminology and vocabulary. So the four key terms I always start with are table, items, primary key, and attributes. And we'll just look at this by way of an example. You could think of like if you have users or customers or whatever in your application, you might have them here. So I have a bunch of records in my application, and all those records together are going to be called a table. So table in DynamoDB, similar in some ways to a table in a relational database, but different in other ways that can be confusing as well. And we'll get into those. So all my records together are going to be a table. If I look at an individual record, that's going to be called an item. So an item is an individual DynamoDB record, similar to a row in a relational database or a document in MongoDB. That's going to be an individual record. Now, when you create your table, you have to specify what's called a primary key on your table. And every item in your table needs to include that primary key and must be uniquely identified by that primary key. So you can see on the left-hand side here, we have this primary key, its email address, and that's how we're identifying our users and our customers, right? We don't want multiple users or customers with the same email address. So that makes it a good primary key. It's unique. It's how we're going to look up our users there. Now, in addition to that primary key, you can have other attributes on your items. So similar in some ways to columns in a relational database, but the big difference here being you're not going to declare these attributes up front like you would columns in a relational database. So DynamoDB is schemaless. You don't have to declare a schema up front. It doesn't mean you shouldn't have a schema, but that schema validation and checking should be in your application before you write to Dynamo, when you read back from Dynamo, rather than relying on the database to maintain that schema for you. If you look at these attributes, you can have simple attributes that are strings or numbers, first name, last name here, but you can also have complex attributes like lists and sets and maps and different things like that. I want to talk a little bit more about the primary key because it's super important to how Dynamo works. So there are actually two types of primary keys. Again, these are declared on your table when you create that table. The first type is what's called a simple primary key, and this has one element called a partition key. And the second type is a composite primary key, which has two elements, partition key and a sort key. So going back to our example that we already had with our customers in there, that's an example of a simple primary key. That primary key has one element, that email address that uniquely identifies each record in our table. You can imagine maybe we're making like an e-commerce application where customers are making orders, right? And so we have this table with a composite primary key here that's storing our orders. You can see I have the composite primary key has two different elements. It has that partition key. This is going to be customer email. Again, we'll use that as a partition key. But then it also has this sort key of order ID. And it's the combination of those two elements, the partition key and the sort key, that are going to uniquely identify an item in your table with a composite primary key. Last thing I want to point out, just in terms of how this modeling works, because I'm going to show a lot of these images. If you look at the top there, those are two distinct items that we have there in our table, two different orders. Even though they happen to have the same partition key, And the modeling software I'm using here, it sort of merges those together because items that have the same partition key are going to be located near each other. They're going to be ordered according to that sort key, and you can fetch them together in a single request with a query operation. So you can do a query that says, hey, give me all the orders for this customer with this email address, and it very efficiently goes and fetches those orders. So get all the orders for a given email, very efficient operation in Dynamo as this table is set up. That term for items that have the same partition key, that's going to be an item collection. Pretty important to how you do data modeling in Dynamo. All right, so that's a basic terminology. Let's do what I call from SQL to NoSQL. I'm assuming most of you have like a SQL background and understand how relational databases work. NoSQL databases are very different, and there are a lot of different flavors of them. Dynamo is a specific flavor. So I want to talk a little bit about like why Dynamo exists, why it does the things it does, and things like that, because some of the modeling stuff is very different from relational databases. So I like to think of it in 3 steps: goals, choices, implications, right? So goals, when the AWS team set out to make DynamoDB, what were the goals they had in it? Like, why did they make this new product separate from a relational database that had that? So like, what were they trying to get that a relational database wasn't giving them? And then given those goals, what are the choices they made and how they designed DynamoDB and sort of the API they expose to users and the things they do and don't do to help implement those goals? And then finally, given those choices, given how they've built it, how they've exposed it to us, what are the implications for us using DynamoDB? So let's start off with goals. 3 big goals I think that Dynamo has as compared to relational databases. The first one is about consistency, and consistency is really about consistency of performance in a lot of cases. So one chart I like to show is this, and on the x-axis here, I have data size, right? So as you go further out on the x-axis, you're putting more and more data into your database. And then on the y-axis, we have performance, right? And you can think, as you go higher here, think of it similar to latency, right? As you go higher here, the slower and slower that performance is going to be. Now, this isn't drawn to scale or anything, but generally with a relational database, you'll see a curve that's sort of like this, where it starts off really nice and gets slower over time. So, in your test environment or when you release that your new product, right, and all the data still fits into memory, it's super fast and everybody's happy about it. But then you get 6 months, a year, 2 years down the road, and it's starting to feel sluggish. Things that were working fast before, they're not working as fast as you get more data. You have to go investigate and say, hey, do I need a new index? Do I need to denormalize in some way? Do I need to do something else, increase my instance size? And then at some point, it gets so painful and slow, and you've done all that you can do that you might have to re-architect, right, and redesign your data model, whether that's on a SQL database still or on some other type of database. So that's just the general curve of how relational databases work. In contrast, Dynamo has a performance curve that's more like this. It's completely flat, right? And you should expect the same performance in a test environment, staging environment, day 1 of your application, 2 years down the road, 10 years down the road. It doesn't matter how much data you have in your application. You should get pretty consistent performance on an individual request. And data size is one thing that impacts performance for relational databases, but you can also change that x-axis to be concurrent queries. How many concurrent operations am I doing against my database? And again, same thing. As you do more and more concurrent queries, that performance starts to degrade and get really slow, whereas Dynamo is going to be pretty consistent there. So consistency, that was one of the main goals of the DynamoDB team as they're designing it. So they want to give you the same response time regardless of database size and regardless of number of concurrent queries. And it makes it really helpful and about understanding what you're going to get out of this system down the road. And sometimes I show this chart and my relational database friends, I love relational databases, but some people are like, hey, you can get the same thing with relational databases, just don't use this feature, don't use that feature and things like that. I think one thing Dynamo wants to do is reduce the need for sort of deep expertise and how much you need to tune your table or avoid certain features or things like that. And there's this really good quote I like from this guy named Nelson Elhadj, used to work for Stripe. And he talks about how he loves relational databases, but his biggest problem with them is the feature surface is so big that it's really hard to know what the operational implications of any one feature is. And like the easy example of this is like, hey, Postgres offers full text search. You can add that on a column. And that's going to work pretty well at low scales, medium scales, but at some point that's going to blow up and not work as well for you. So, and it's hard to know that until you've actually, cut yourself on it. So I think that's one of the things about consistency. One of the goals there is consistency. Let's move into the second goal, which is around predictability. And part of that predictability is just around performance, right? Because it has that flat performance curve, I can do some testing in a local environment, or in a dev environment, do some load testing, and I'll have a pretty good idea of how that's going to perform much later down the line, which is more difficult to do in sort of a reliable way with your other databases. So it's partly around performance, but it's also predictability around billing. And I think Dynamo has an interesting billing model. So with traditional databases, you're going to be paying for instances, rather than, you're going to pay for resources rather than something else. So with Dynamo, you're going to pay for reads and writes directly rather than resources. And this is really interesting, right? With relational databases, you pay for CPU, for RAM, for disk, network, whatever it is, you're paying for that. But Dynamo is saying, hey, you just pay us for what are called read capacity units. That's saying, hey, you can read 4 kilobytes of data, or write capacity units. You can write 1 kilobyte of data. And the great thing about this is that it gives you that predictability around instance sizing, around predicting how much you need. Because I think sort of prediction around that stuff is really hard, because even if you're talking about a relational database, even if hey, this is how much traffic we assume we'll get per second or something like that, turning that into raw resources like CPU and RAM, it's really hard to do. You can do some tests, but they're not going to be representative. Whereas Dynamo, you can do this in a spreadsheet pretty easily. If you have 2 kilobyte user items, you're going to do this many requests per second, you can calculate how much capacity you need. You can say, well, what if it's 2x that or 10x that, and have a pretty good idea. In addition to that, Dynamo has 2 different billing modes. They have provision mode, which is just saying up front, hey, I want to have this much capacity available on a per second basis, reads and writes, scaled out up and down as needed. Or you can just say, hey, I don't know how much I'm going to use. I just want to use on-demand serverless pay-per-use mode, where I'll issue reads and writes against this database, and you just send me a bill at the end of the month based on the number of reads and writes I've done. And the greatest thing I love about this billing is like I was saying, you can do the math. You can get out a spreadsheet, figure out how big your items are, try to guess at your traffic, and get a sense of like what that's actually going to cost you and how much it's going to cost you as that increases over time. So that's the second goal of Dynamo, is that predictability. The last goal of Dynamo is just reliability. And the great thing about Dynamo is it's very reliable. It's a fully managed service, which we're moving more and more into like managed services, especially in databases, with RDS and things like that on Amazon. And those are managed, but they're still partly managed, right? You're still responsible for like scheduling upgrade windows and a little bit of failover type stuff and things like that. And if you overload your instance, you can take your own instance down. Elasticsearch, I think, is the classic example of this, where I've had a managed Elasticsearch service before, and you can just overload it with so much queries where it just falls over, and now you have to spend hours rebuilding that index. Dynamo doesn't want to let you do that, right? They're going to be a fully managed service. It's a multi-tenant service. You can't overload it and take it down like that. Very few outages of the DynamoDB service. They're every 2 or 3 years, maybe they have an outage, and even that, it takes down half the internet anyway, so most people aren't noticing. But if you do, if you can't handle those outages, you can use what are called DynamoDB global tables, because an outage is usually going to be in one region, where global tables would be like a multi-region replication system going on, so you can just fail over to another region if you need to. So those are the 3 goals that Dynamo's going for: consistency, predictability, reliability. Let's move from goals to choices and understand what choices did Dynamo make to implement those goals. And the first choice they make is really relying on the importance of that primary key. So we go back to our table we had here, our orders table, and I talked about that primary key. And when you're working with this table, you want to query with that primary key. You want to query with that customer email, maybe with that order ID in there, but you don't want to query with those other attributes, those schemaless attributes that are included in your items as well. And to understand why that happens, let's just understand a little bit about DynamoDB's architecture. So, Dynamo is built for massive scale, and one of the ways they do that is horizontally scale. They don't store all your data on a single instance. They're going to chop it up behind the scenes onto different instances, and these are going to be called partitions, right? So partitions are going to hold a subset of your data. These partitions are going to be a maximum of 10 gigabytes in size. So imagine you have a DynamoDB table that has like 15, 20 gigs. In it, you'll have these 2 partitions here. And now if imagine a write request comes in, you say, hey, this user, Alex DeBrie, wanted to make an order on my e-commerce application. It's going to hit that DynamoDB front end. That DynamoDB front end is going to look up your table metadata, figure out what the partition key is, and figure out which partition it belongs to. So based on that partition key, you can say, oh, this item belongs on partition 1, and I'm going to go write it to partition 1. And the great thing about this is, as my table scales from 15 to 20 gigs to 25, 30 gigs, I can add a third partition. I could add 6 more partitions. I could add thousands and thousands more partitions. But this whole operation is going to be efficient because that first step is basically a constant time operation to figure out which partition it goes to. So even if you have a terabyte or petabyte level table with thousands and thousands of partitions on it, it's doing a constant time operation to immediately find the right partition and shrink it down to about 10 gigabytes, which is a lot quicker for Dynamo to play with there. So that primary key is very important. That partition key in particular is important as it's partitioning and sort of assigning your data based on that. Another thing that's interesting about Dynamo is it has very clear, harsh limits. And this was tough for me at first with Dynamo, but I've really grown to appreciate it because whatever database you're using, it has some limits somewhere, right? If you provision a Postgres instance, it has a limit on the number of queries that you're going to do. And I think the hard thing with most databases is you don't know where that limit is. You sort of just push it until performance starts to degrade or until it falls over. Dynamo sort of protects you from yourself and gives you harsh limits. So one of the limits it gives you is, hey, if you're doing a query or a scan operation, this is reading multiple items from DynamoDB, it's only going to give you a megabyte of data back at a time, right? So if we go back to our example orders table, and I want to get all the orders for Alex DeBrie, maybe I could fetch that, and I could get all those orders back, and that's going to be a very quick operation when I only have 2 items. But you can imagine, over time, I keep coming back to this store and I make lots and lots of orders. Maybe I'm ordering weekly or daily or however. I've got lots of orders, maybe a gigabyte of data in there. And now if I fetch all the orders for Alex DeBrie, it's a lot of data, right? Maybe it's megs and megs of data. I don't want to return that all at once because now we've lost the consistency of performance, the predictability of performance. So it's saying, I'm going to cut you off at a megabyte and I'm only going to return a megabyte of data. And if you want more, I'll send you back a pagination token and you need to handle that. But you need to think now about pagination. You need to think about how you're going to deal with large result sets in your data so that we can maintain that consistency of performance in your application. So Dynamo doesn't love things that are unbounded, right? Unbounded amount of records here, they're going to cut you off at a specific limit. Another limit Dynamo has are what are called partition throughput limits, right? So let's go back to our understanding of Dynamo infrastructure. We have all these different partitions, right? And ideally, our data is spread pretty well across those partitions. But you can imagine having sort of an unbalanced workload where we're just nailing one partition with all these requests. And it's so many requests that partition is starting to get overloaded. Rather than like degrading performance for you, what Dynamo is going to do is set up these hard limits on an individual partition. So it says, hey, you can only do 1,000 write capacity units or 3,000 read capacity units per second on an individual partition, right? And this is a lot of data. That's 1,000 megs of data, 12,000, 1,000 megs you can write, 12,000 megs you can read. So it's a lot of data that we're talking about you can do here. But if you start to exceed that on a per second basis, it's just going to throttle that back at you rather than sort of performing more slowly. It's going to throttle it back and it turns failure into a binary. Either this operation succeeds and it succeeds within this consistent predictable time, or it fails very quickly back at you. So clear harsh limits, that's another choice they made for you that helps with reliability and that consistency and predictability of performance. The final choice is just around the API with Dynamo, right? They've removed features that don't scale super well. And the two that people always notice, are no joins and no aggregations. And again, that gets into that unbounded nature with Dynamo. Dynamo doesn't like unbounded things. But with joins, with aggregations, you're working against a potentially unbounded number of rows. And Dynamo doesn't like that, so they're just going to kick it out. And again, this goes back to Nelson Elhaj, right, where it's hard to know what the operational implications of these features are. So what Dynamo does is it just says, hey, we're looking at all these database features, and the ones that scale well, we're going to offer you. The ones that don't scale well, we're not going to offer you, and you have to figure out other workarounds for that. And that's one thing we'll talk about in the last section of this talk. So just looking at the SQL query, say we want to sum up the total order amount for a particular customer, and we have to join two tables together. And then once we've done that, we have to sum up this unbounded number of records. again, if there are only 2 records, that's a pretty quick, efficient operation. I can sum these up and get $89 or whatever. But if I have this unbounded number of records, now I don't know how many records I'm gonna have to scan through. Maybe it's less than a meg, but maybe it's gigabytes and gigabytes and gigabytes, and they don't want to give you that unbounded operation. So they just don't let you do that. So those are the 3 choices Dynamo makes in sort of in service of those goals that we already talked about. Last thing, let's talk about the implications for you. Dynamo sort of has this more restricted API on how it works. How do you sort of use that? How do you change your modeling as compared to a relational database? I think the biggest thing is more of the hard work is upfront with DynamoDB. So in a relational database, you think about the different objects you have in your application and how they relate to each other. And you take each object, each one gets its nice normalized table. You set it up that way. Maybe you set up these foreign keys across these to link them together. And then you start to think, how am I going to access that data? Do I need to add indexes? Here's the query I need to write, things like that. But you sort of data first, queries second. With Dynamo, you want to think queries first and then model your data based on that, right? So you want to design for your access patterns specifically. And that's how you'll set up your primary keys based on how you'll actually read and write that data. That's how you're going to design that. Another thing you're probably going to need to do is maintain aggregations. And we'll talk about this in a second, but like Dynamo doesn't do aggregations, but that doesn't mean you don't have aggregation needs in your application. So you need to think about other ways to do that. And we'll talk about strategies for that in a second. You also need to think about pagination and sorting, right? If you can only fetch a megabyte of data, you need to think, what if my result size is more than that? How am I going to expose that to the user? You also need to think about sorting up front, because the sort key in your composite primary key is how those items are going to be sorted. So you sort of want to pre-sort them as you want to show them to users. And you might need to shard if needed, right? If you're going to overload a particular partition with too many requests per second, now you need to shard that across multiple partitions and think about that. So the big change with Dynamo is, hey, a lot of that hard work is up front. A second change or a second implication for you is you want to use secondary indexes. And to understand why we need those, let's go back to our orders table that we talked about before, right? It's very easy for me to go to this table and look up an individual order if I have the customer email and the order ID, right? I can do that, do a very quick get item. I can also do a query operation using that customer email to get all the orders for a particular customer based on that email. But if I want to find an order just by the order ID, say that the warehouse is processing this, I can't do this, right? Because that partition key is used to sort of spread that data around, and I don't know the partition key here. I just have this order ID. So how do I do that lookup there? What you can do is if you have additional access patterns based on different attributes that aren't in your main primary key, you can add secondary indexes. And you'll add this on your table and you'll say, hey, I want a secondary index where the primary key is order ID, right? And what Dynamo is going to do is take that data from your main table, replicate it into this secondary index. It's just like a DynamoDB table, but it's a read-only copy of your data. You can see it has a different primary key. This is the exact same data. It's just reordered in a different way to allow you to use a different primary key here. And now you can go find that order item that you are looking for on this secondary index. So secondary index, again, the key here is data from your main table is going to be copied into this secondary index with this new primary key. So it's just a copy of your table that Dynamo is maintaining for you. And then you can do read-based operations on those secondary indexes. So if you have multiple access patterns, use secondary indexes for those. Note that you can't write to your secondary index. You can only write to your main table, and then that's replicated outward. So think about your write access patterns as well and how you sort of want to handle those in your main table. All right, so that's secondary indexes. The next thing is called, you might hear about something called single table design with Dynamo. And if you're using that or have read about Dynamo, that might be confusing to you. Or if you're like on the analytics team and someone on the user facing side has a DynamoDB table using single table design, you're like, how do I get this in my analytics system? Let's walk through what single table design is, why it might be useful. The idea with single table design is, rather than having separate tables for each of your objects, each of your entities in your application, you might combine them all into a single DynamoDB table. So the example here, we'll stick with that e-commerce application. Imagine we have 2 different entities, customers and orders. I've been showing them in 2 different tables, but let's just put them in the same table and see what that would look like. I'll start off with customers first. You can see I've got two customers in this table, Alex DeBrie and Jen Sample. A couple things I want to point out here. Notice that my primary key names are very generic, right? Instead of using things like customer email and order ID for those primary key elements, I'm using very generic names. PK for partition key and sort key, SK for sort key, right? And the reason I'm doing that is because different entities are going to have different attributes, right? My user entity doesn't have an order ID, so it wouldn't make sense for me to name one of my keys that. So I'm using these generic attribute names here. Addition, if you look at the values there, they're going to be sort of weird values that might be have a prefix of like what the item type is. It could also include multiple different values encoded in that item in there. So there we've got our two user items in there. Let's add a few order items to this table. Notice that we still have our two user items outlined in red there, but we've now added these three order items to our table. A couple things I want to call out here. Notice that the pattern for the primary key values are different, right? So for user, it was user hash email address. For order, it's order hash order ID, right? So you're gonna have different patterns for different types of entities. Also, if you look at the actual attributes for each of those different types of entities, note they're totally different attribute names, right? And this is where DynamoDB's schemaless nature comes in. You don't have to have the same sorts of attributes. So customers can have attributes that are related to customer, first name, last name profiles, where orders can have attributes that are related to orders, order date, order amount, order status. One last thing I want to call out, and it's sort of like, why would we do this sort of thing, right? We talked about this notion of an item collection earlier, where all items that have the same partition key are said to be in the same item collection. You can retrieve those with a query operation. You can see I have an item collection here, and I actually have two different types of entities in this item collection, right? So I have my customer entity, right, at the top, but I also have two order entities. And the reason that this is nice is I can't do joins at read time in Dynamo, but I can sort of pre-join my data at write time, right? If I need to fetch all the orders for a customer, but I also need to fetch that customer record so that I can sort of enrich those orders with some of that information, I can put them all together in the same item collection. That's a quick query operation. I basically pre-joined at write time to enable that sort of access pattern. So it's very efficient there. Again, this is called an item collection. That's one of the reasons you might do single table design in Dynamo is to enable that sort of thing. All right, last implication with Dynamo is you need to get comfortable with denormalization. And denormalization is sort of a bad word as you're learning SQL and things where you want to normalize your data, have it in third normal form. But as you work on higher scale SQL applications, a lot of times you're denormalizing in certain ways for performance reasons, and you do the same thing with Dynamo, right? So one reason might be if you can use complex attributes. So I talked earlier about you can use lists and sets and maps in your attributes, right? And so if you have a one-to-many relationship, you sometimes might just encode that data on the parent item rather than splitting it out as a separate record. Another way you might denormalize is just duplicate some information about multiple different things. Like, hey, if there's certain parts of a customer that don't change very much or aren't even allowed to change, maybe you just replicate that information onto those order items. So you don't need to go fetch that customer record in order to enrich that. So you need to get comfortable with denormalization there. All right, so that's sort of the intro stuff. That's like how DynamoDB works, why it works, like why it is the way it is. Let's move into the analytics section and talk about, hey, if I have some analytics like needs in Dynamo, how do I solve that? And again, just to recap some of the things that we talked about before, we're talking about choices. Dynamo doesn't have aggregations, and when we're talking about analytics, it's often about aggregations, grouping a lot of records together and running sums or averages or maximums or something like that. To look for some information there. Dynamo doesn't provide that. Again, Dynamo also has these clear, harsh limits where you can only be operating on a meg of data at a time. So if you're talking about analytics where you're often working on gigs and gigs or maybe even terabytes and petabytes of data at a time, right, to generate these insights, Dynamo is not going to let anything like that. So what are the patterns we have for analytics in Dynamo? And I would say you really need to think about your needs, what kind of analytics you're actually doing. So the first type is what I call customer facing analytics, right? So maybe you want to show your customers, your users, some analytics related to their data or something they're doing. And an example here might be, I got this from my Amazon.com profile. If I go to my orders page, it shows me a sum of the number of orders I placed in 2015 here. So in 2015, we made 11 orders on Amazon. And go back to Dynamo and think about it. And Dynamo doesn't do aggregation, so I can't just say, count star from the orders table or something like that for this user. So how do I handle something like that, right? And if we go back to our single table design, one thing I could do is just on my customer record, add this attribute called total orders, right? And every time I place a new order in my table, I'll also increment this total orders record for that particular customer, right? So what I'm doing is I'm aggregating at write time rather than at read time, so that the read time aggregation is still very quick, right? I'm just looking up a record for that. So that's one thing you can do. And you can see here, I'm just keeping track of total orders. But if you go back and look at that Amazon page, it's saying how many orders were placed in, and it allows me to sort of choose a time period, right? And I can choose all these different time periods by year, last 3 months, last 30 days, all sorts of things like that. So I can't just keep track of my total orders. I need to break it down in some way. So what you might do if you want to provide better granularity is you could break it down like this, and you could say, here are the orders for September 2022. Here are the orders for August 2022. And every time someone makes an order, you have to increment a particular month rather than a year. So you sort of need to make that balance there. So if we're talking about customer-facing analytics in Dynamo, what you're going to want to do is you're going to want to pre-aggregate based on your needs. And if you have predictable needs about the aggregations you want to show, like the total number of orders in these very predictable time periods, that's a pretty easy thing for you to do in Dynamo. So that works really well if you have needs with pretty limited flexibility. Like I couldn't go to that orders page and get really flexible or filter out certain orders or different things like that. Worked pretty well. The big trade-off you need to think about is granularity versus size, right? Like I'm showing, if it wanted to let me group by year, hey, now I need to sort of group them by year and figure that out, or group them by month. Sort of the more granular you allow your customers to look at aggregations, the more data you need to store to make that happen at read time. Now, what if you need more flexible querying, more flexible analytics, things like that? That's where pre-aggregation is going to be tough. And the thing I would say here is like, what if I could say, get all my orders that ship to this address between this date range, between this amount, right? Or maybe I don't have to even say an amount, or things like I just have a lot of flexible options as I'm doing aggregations. Dynamo is probably not going to be the right tool for you there. Then you want to look at it, some sort of external system. Elasticsearch for a long time was like the common one to do this sort of thing. That operationally just makes me terrified. There's another tool called Rockset that I recommend to almost everyone. I love that team. I've done some stuff with them and recommend them to a lot of people. And they'll just sort of hook into your DynamoDB table, ingest that data, and allow you to run SQL analytics very quickly on that. So check out both those systems. All right, so that's the first pattern of analytics. What if I have customer-facing analytics? The next pattern is probably more common for y'all, I guess. Oh, so that's pre-aggregate or use an external system. Then the next pattern is probably more common. That's going to be internal analytics, right? If I'm a PM or a business analyst or the CEO or whatever, and I want to know what's happening in my application, how do I do some analytics there? And we have a couple different patterns there. Let's just talk generally about the problem of internal analytics, right? Where you have probably some production databases. It might be NoSQL, it might be DynamoDB. You might also have like some clickstream or event type data, something like segment happening somewhere. And those are all serving one purpose, but then you want to get them somewhere else, like into Redshift or into Snowflake, things that are built for OLAP, built for these giant, massive parallel queries. How do you make that happen? And the problem here is you have very high traffic data coming into these production data sources, right? Lots and lots of small operations happening to those. But then you want to get it to Redshift and Snowflake, and they don't like lots of little operations. They like fewer, larger operations, right? And generally what you'll do is you'll have some sort of piping system in the middle where that data somehow gets either to S3 or maybe into Kafka, something like that. And then you have a fatter pipe that feeds that into Redshift and Snowflake and things like that. So this is like the general problem of analytics, right? How do I get lots of little operations into fewer big operations into my fat databases? So thinking about how you do that from DynamoDB, there are really two options that I recommend to folks. One is DynamoDB streams into S3, and then from S3, whether you're operating it there or somewhere else. So let's talk about DynamoDB streams. If you have your DynamoDB table, you can configure what are called DynamoDB streams on your table. So you can add a DynamoDB stream. And now what's happening is all these operations are happening against your DynamoDB table. You're writing data, you're reading data, you're deleting data, all that stuff. If you have streams enabled, every single write operation that happens against your table is going to get dropped into the stream in order. So every insert, update, delete will get put into that DynamoDB stream. It's just like a change log of what's happened in your database. And now you can take that and sort of act on it, and just like you would with Kafka or Kinesis or something like that. And a very common thing is just, hey, store this into S3, right? Get it onto S3. And then once it's on S3, I can use Athena to query it. I can load it into Redshift or Snowflake or do whatever there. So the pattern here is just take all these writes, feed them through the stream, and then get them into your analytical system, right? This is really good for large amounts of data that's immutable, right? If you have a lot of clickstream-like things or data records that don't change a lot, this is a good pattern for it because just in terms of the immutability part, it's kind of hard to mutate individual items in data warehouses. Some will allow it, some won't. Even the ones that do are kind of slow about it, especially if you have lots of little mutations. So you don't want to be having highly mutable data going into your warehouse. But if you have pretty immutable data, you can just be streaming this out in basically real time and getting it into your database. The second pattern you can use is export your table to S3, right? So you can go to Dynamo and they actually have an option. You can click a button and just export that entire thing to S3. And you can do that in JSON, you can do it in ION format, a few different things. And once it's in S3, then again, you can query it with Athena, you can load it into Redshift, Snowflake, do whatever you want with it there. So export to S3, that's the second option. Note that this one is priced per gigabyte of data during that job. So I like to say that this is better for smaller mutable data. And the reason I say that smaller, you're gonna have to pay for this per gig every time you do it. So this is probably something you wanna do maybe daily, maybe weekly, something like that, but some sort of amount of refresh time. This is more of a batch operation. But if you have highly mutable data, maybe like the core data in your application, like users or something like that, that's mutating a lot, rather than changing those in your data warehouse one at a time via DynamoDB streams, it might be better to just say, hey, this changes just once a day or once a week. We're going to sort of dump the whole thing, delete our entire table in Redshift and load in this new fresher data, right? And if it's a smaller data set as compared to like clickstream actions, that's not going to cost you as much, and that might be a better option there. And really, it might be a combination of those two, right? But in terms of internal analytics, I generally recommend DynamoDB streams for large immutable data and then exporting to S3 for small mutable data. And which one of those fits for you, it depends on how price sensitive you are, how real time you want that data. DynamoDB streams can be more real time, where exports can be more batch, a little more out of date. But yeah, you can sort of decide on your needs there. All right, last pattern we have here. This is a little different, but like just serving generated data back to your users. So sort of like customer-facing analytics. But again, if we go to our system, we have all this stuff happening against our operational data. But what you might do is take all that operational data, put it into S3, and maybe now you have some sort of offline process to generate recommendations. Maybe it's friends for a user, friend recommendations for a user on a social network. Maybe it's product recommendations on an e-commerce site, something like that. You'll sort of generate these. Maybe they're specific to a user, something like that. And then once you've generated those, you need to store them someplace that you can easily and quickly serve them up to your users. And Dynamo is great for that, right? It's usually going to be a key-based lookup, a very easy read. It's a fully managed database. You don't need sort of super flexible querying stuff on there. It's usually just like hash table type stuff. So DynamoDB can be a great fit right in there for serving generated data. That can handle very high number of reads there. So those are the three big patterns for Dynamo. Again, think of what sort of needs you want. Hey, is it customer-facing analytics? Well, then I'm probably going to need to do some pre-aggregation. If it's very flexible, I'll look to an external system. If it's internal analytics, how am I going to get that out of DynamoDB efficiently? It can be DynamoDB streams. It can be export to S3. And then finally, I might need to serve generated data, and Dynamo can be a good tool for that. All right, summary, and then we'll take some questions. Again, we just started off with some basics on Dynamo around terminology and concepts there, and then went into that from SQL to NoSQL to get an understanding of how Dynamo is different than relational databases, what it was aiming at, and what that led to in terms of choices and the implications to you in your modeling. And then close it off with some of those patterns and analytics, both for customer-facing, internal analytics as well. So yeah, thank you. Happy to answer any questions, things like that.
Okay. Wow, that was so cool. I almost forgot that I'm a host. I was listening here so hard. This was very, very cool.
Thank you.
Okay. Back to my role. I'm checking the questions. We have actually plenty of them. So I will go with the one that has most of the votes. So the first one is how to predict read and write capacity units in an efficient and accurate way on the design stage.
Yeah, that's pretty tricky. I would say, like, if you have a sense of how much traffic you're predicting, I mean, that's always the difficulty of sort of capacity planning and things like that. How much traffic are you predicting? If you don't have a sense of how much traffic you're actually predicting, maybe you don't do that at all. Maybe you just say, we're going to get this out there. We're going to do on-demand billing to start, and just say, rather than trying to do provision capacity and tune that well, I'll do on-demand capacity. This is going to be more expensive than provision capacity on sort of like a per request basis. But it can be a good way to sort of figure out what your capacity needs are. And then once you know that baseline and sort of what your traffic looks like, you can switch to provision capacity then to reduce your cost and sort of adjust that as you need to. So Dynamo is pretty it's pretty flexible in allowing you to sort of switch between modes, even if you're doing provision, to sort of scale up, scale down, and things like that.
Nice. Okay, so the next one, can users manage number of partitions, or it's happening without user interaction?
Yeah, that's a good question. So I talk about all that partition stuff, but that's completely hidden from you as a user. You don't need to know about that stuff at all, which is nice. I like to teach it because I think it helps you understand and build a mental model of, like, why is my partition required in every single operation? My partition key required in every single operation. It helps you, like, understand that. But that's totally managed for you behind the scenes. And really, I barely skim the surface. Like, Dynamo is, I said that Dynamo is going to give you a partition for every 10 gigs of data, but it's actually based on three different things: how much data you have, sort of how much throughput you've provisioned. They might give you more partitions. Or even if you have like one partition that's receiving a lot of traffic, they might split that apart into two partitions just to sort of spread the heat on that across multiple partitions. So that's all transparent to you. You don't really need to think about it. And you don't decide how many partitions you have, really.
Wow, that's something that feels like makes life of engineers so easy. Whenever you don't have to think about the stuff and everything is managed instead of you. That's great.
That's what I like. I just can't even go back to to other databases. Like, I understand there are good use cases for other ones, but they're just like so many things. I don't want to have to think about that in terms of partition management, unpredictable scaling, things like that. Yeah, absolutely.
Okay, so the next one, if we do data selection by non-primary key column, will not it take long time, as there are no indices on the columns like in SQL database?
Yeah, correct. So, I mean, you can't even really select by non-primary key. I mean, if you wanted to basically filter by the non-primary key, you would have to do a scan operation, which is going to look at all the data in your database. And again, it's only going to do it 1 megabyte at a time, because that's that page size limit. So if you had a 1 gig database, which isn't even that big, it's going to take you 1,000 sequential requests to go through all that. So not super efficient. But if you do have additional patterns based on other things, if you want additional ways to access it, you can use secondary indexes. I talked about that a bit, where And it's basically like adding a new primary key to your table. They're going to replicate that data into a copy of that on new partitions somewhere else, and you can query that very efficiently there.
That makes a lot of sense. Okay, the next one, how to make changes into a single table design if the system is already in production.
Yeah, sure.
That's probably a tricky
That's
one.
like that. I get that all the time. Like migrations. How do I do migrations? It's a bigger topic, but the big thing I would say is like understand what type of migration you're doing. Right? If you have a single table design that has a lot of entities and you're like, hey, I need to add a new type of entity into my application. How do I model that? Well, that's pretty easy. Like you don't need to change anything in your table. You just sort of design the key for that and you can start writing that entity in there and you're good. Same thing is like if you have an existing entity and you want to have like a new attribute on that entity, you're changing your schema a little bit, but it's not something you're actually reading your data by. Well, all you really need to do is change your code there. And what you could do is just have a default value in your code where when you're reading that item back from Dynamo, if it doesn't have that value, you just insert the default value and then hand it off to the rest of your application to operate on. The harder question is like, what if I have new ways to access my data? I need to read my data in a new way, right? And fortunately, you can add secondary indexes at any time and it'll backfill that for you. Sometimes you might need to create a new attribute on existing items that you're going to sort of index by. And to do that, you basically need to do an in-place ETL operation. So you do some background process to scan your table. When you find an item that needs that new attribute, you just run an update operation on that table and then keep scanning through your table. So it's a very formulaic process. It feels hard, but once you do it like one or two times, you probably have a framework for it at your company. It's very easy where you scan your table, identify what needs updated, update that item, then keep paginating through until you've done your whole table.
Oh, yeah. You have to have a practice to make sure it's going to be easy for you.
Yeah. And that's like the 2-minute explanation of it. Like it's not that much more complicated, but at least like showing the example. I have some slides on that elsewhere, but like, yeah, it's not as scary as you think is what I would say.
Yeah, it feels like you have this workflow in your head that if you need this, then go that direction, and yeah, like a whole graph of decisions.
It's true. And like, that's really what it is. It's like breaking down a problem into solutions. Like even with analytics, right? Where it's like people say, how do I do analytics with Dynamo? And it's like, well, are you talking about customer facing analytics? Are you talking about internal analytics? Are you talking about serving up recommendations? Like think about that. And then you can get more specific. Like there's an answer to each one of these, but like break down your problem first. Don't let it loom so large in your mind and then it gets easier.
Okay, heading to the next question. If we have a JSON in the secondary key column, is it correct found by this field separate property? Okay. Is it correct maybe to found by this field separate property?
So if I understand the question correctly, he's saying like, can I have a JSON attribute, an attribute that it has like a map or a list or something like that, that I want to use in a secondary index? And the answer is you can't. For your primary key and for your secondary index attributes, you can only use strings, numbers, binary. So it has to be like scalar values. So yeah, you can't index on a map or a list or anything like that.
Okay. Okay, I think this will be over the last one, but anyway, let's try. How would you store orders contents? Can you put a partition inside a partition for multi-layer data storage?
Yeah, so that's a good question. So like you're right on that. Those sort of order items I was showing, I didn't include the contents of that order, right? Which could be lots of different things. So one question, if I understand it, like we showed an item collection that had the customer and the customer orders themselves. What if I wanted to have a separate row for each item in that order? You could put that all in the same item collection. It wouldn't be like a partition within a partition, but you would just have 3 different types of items in that item collection: the customer, the order, the items of that order, then another order, the items of that order. I usually wouldn't sort of put them together like that in that sort of use case, because if you still had that request, yeah, if you still had that operation of, hey, fetch all the orders for a given customer, what you're going to be doing is you're going to be getting a lot of extraneous items in between that, all these order items. That's going to sort of blow up your request size and things like that. So what I would probably do is have a secondary index, because it's unlikely you're going to say, hey, give me all the orders, including all the items in that order in a single request, like a lot of them. What I'd probably do is have two different, access patterns. One would be the customer and the customer orders, like the top level summary view in one item collection. Then in a secondary index, we'd re-index that order and the contents of that order, so you could fetch those very efficiently for like a detail view of a particular order.
I got it. I hope that the person who asked it also understood your answer.
I would say, yeah. Hold on. I have a post on my blog that's about like DynamoDB one-to-many relationships that basically has that exact same example. And if you look at the third, and I thought it was the exact same example. It's the same concepts, but it's not e-commerce. It's something else. But if you look at the third and fourth ways to model one-to-many relationships, it addresses basically that exact question.
Okay, so we now have a homework. Review your blog and make sure we understand the one-to-many case.
Yep.
Okay, I think it's all of our time for the questions. And now the most complicated part. You need to select 2 questions that you like the most so we can give gifts to people.
Perfect. Okay, I would say let's do the question about partitions. That was a good one. Like, do I choose my partitions, or is that just happening for me? So I'd say that's a good one, because I think it really clarified something I totally missed there. And then the question about migrations, I think that's a great one. It's one of the biggest objections I get to Dynamo. How do I do migrations? It's great if you know your patterns up front. So I think it was a good thing to talk about and understand. Even though we couldn't get super deep into it, I think, like, hey, go do some research on there. Reach out to me after if you want to. Like, these are absolutely doable in Dynamo. So great questions all around, but those are the 2 I pick.
Okay. Thank you very much for your presentation. It was just a pleasure to listen to you speak. It was absolutely great. I learned so much new things, and I already start thinking, where can I use DynamoDB to actually try everything on practice about what you told us. So thank you very much, and I hope to meet you on other meetups too.
Absolutely. Likewise. Thank you so much for having me. Looking forward to Terrace's talk as well.